Hello. These are your notes for section 3.3 in algebra. A little bit of vocabulary to start with. Talking about an x-intercept, something you've probably heard before. It is where the graph crosses the x-axis. Good name for it, huh? X-intercept, x-axis. And is written as a point. Always the number goes in for x, 0 goes in for y. Why, you might say? Makes sense that we have x. If this is our graph, our x-axis goes like this. We can move it any direction that we want, or not any direction, any amount that we want. X could be 1 or 2 or 3 or 4 or 5 or negative 1 or 2 or 3 or negative 5, but it goes up and down 0. So if any number, any coordinate has a 0 in the y, it means that it's going to be on the x-axis. Y-intercept, the graph crosses the y-axis. And this time the 0 is in the x spot because you can move the y anywhere you want, up or down. You just can't move left or right, because if you move left or right, then it wouldn't be on the graph anymore. So it's going to ask you to find the x-intercept of the graph, 2x plus 7y equals 28. And since we're looking for the x-intercept, we're going to turn our y into a 0. Why? You might ask again. Why are we turning our y into a 0? Because it says the x-intercept always has a y of 0. If it didn't have a y of 0, then the points wouldn't land right on the x-axis. They would be somewhere wherever the y set. The only way they can be directly on the axis is if the y is 0. So we're going to turn our equation into 2x plus 7 times 0 equals 28. Good news for us, even though we've been getting good and better at multi-step equations, when you take anything times 0, it turns into a 0. So all we're left with is a nice, simple, two-step solving equation. 2x equals 28, divide by 2 on both sides, and you get x equals 7, or x equals 14. 28 divided by 2. But you can't leave it as x equals 14, because it's not asking for the answer to an equation. It says find the x-intercept. The x-intercept, I'm going to go back up here again, is a point on a graph, however many spaces over and no spaces up. So your final answer must be written as 14, comma, 0. Our y was 0, our x was 14. When you do this on your homework, on your assignments, on your daily quizzes, on your tests, you've got to answer it with parentheses, a comma, and the 14 in the x spot. Okay, then we're going to go ahead and it's going to ask you to find the y-intercept of that same graph. 2x plus 7y equals 28. This time you have the x turns into a 0. 2 times 0 plus 7y equals 28. When the x turns into a 0, it's gone, and all you're left with is 7y equals 28. Divide by 7 on both sides, and you find out that y equals 4. But again, you don't leave your answer as y equals 4. Go back and check. A y-intercept says don't leave the x-axis. Okay, you can't go left, you can't go right, but you can go up and down. How far can we go up and down? We can go over, left, and right, none, but we can go up 4 spaces. 0, 4 is your intercept. Let's try these. We've got 2 more. Find the x and y intercepts of this problem. Negative 3x plus 5y equals negative 30. We'll start with the x-intercept. When we're looking for the x-intercept, we're going to turn the y into a 0, which means it's gone. Why even write it down? If the y is 0, 5 times 0 is 0, so no need for that term at all. All we have is one-step solving. Don't lose your negatives. X equals negative 3. Negative 30 divided by negative 3, which is positive 10. If you leave it like that, you're going to get some credit for at least doing the math right, but you're not going to get all the credit because you need to answer it as 10, comma, 0. The x is 10. Now, when you're doing the y, you're going to turn the x into a 0, which which means negative 3 times 0 is 0. Please go back up to the original equation. You can't use the one that you made later. So negative 3 times 0 is 0, means we're left with only 5y equals negative 30. Divide by 5, and y equals negative 6, not losing track of that. Again, some credit for getting this far. Full credit if you put 0, comma, negative 6, and the parentheses. There's an x and y intercept. And you'd love it if I'd be like, okay, now you know how to do that. But then there's always this one that's different. Seems like every time in math they're like, yeah, but what if? Here's your yeah, but. What if y equals 4x plus 12? Okay, this time when we're trying to find the x intercept, we turn the y into a 0. Well, we can't just get rid of it. If we just get rid of it, it looks like this. We can't have an equation that's unbalanced and doesn't have anything over on this side of it. Yeah, we turned our y into a 0. You might have to actually write the 0 there if that helps. But just getting rid of it doesn't make a full equation. So when we finish this, we have to have x on one side, number on the other. I don't care which one you move. I'm going to move the negative 12 over here. And you get negative 12 equals 4x. So most of them were one-step solving. This is going to be two-step. Divide by 4, divide by 4. Negative 12 divided by 4 is negative 3. And when you answer negative 3 equals x, doesn't matter what side of the equal sign the x is on because you're not answering it like that. You're answering it like this. Now, please keep in mind, I said go ahead and move the 12 over to the other side. What if you moved the 4x over to the other side? You would have got negative 4x over there. Negative 4x equals positive 12. But when you divide by a negative 4, you get x equals negative 3 anyway. Same answer, just different order. And I know we've been working on practicing making sure the x is on this side, so maybe you feel more comfortable doing it this way. Don't forget to do the rest of the problem. You still now have to find the y-intercept. So in looking for the y-intercept, we are going to turn the x into a 0, but this time we're fine. 4 times 0 is 0. You have a y on this side of the equation. You have a 0 plus 12 over there. We went from a two-step solving equation to a no-step solving equation. It's already solved. 4 times 0 is 0. 0 plus 12 is 12. That's our answer. And as long as it's written in the proper notation, you'll get the right answer. X-intercept, negative 3, 0. Y-intercept, 0, 12. Make sure you know which one is the x-intercept and which one is the y-intercept. Okay, this one is the x-intercept because the x actually has a number in it. This is the y-intercept because the y has a number in it. Let's throw some graphs into this. Now instead of having an equation, you have a graph. They want you to find the intercepts. You're going to find the x-intercept, and you can abbreviate it like that, x-int. The x-intercept is the one that crosses or touches the x-axis. Here's my x-axis. There's my x-intercept. Count it over from the origin from 1, 2, 3, 4, 5. If you tell me the x-intercept is 5, not really okay with that. I would prefer that you tell me the x-intercept is parentheses 5, comma, 0, because that's exactly where that point is on the graph. Y-intercept, go find the y-intercept. Here's your y-axis, start at the origin, count up, 1, 2, 3. Your y-axis went, or your y-intercept went up 3. Be careful on your notation. It did not move over. Didn't move left, didn't move right. 0 on the x, positive 3 on the y-intercept. Try this one by yourself. See what you get. Go ahead, pause the video. Pause it. Pause it. All right, you're back. You should have an x-intercept of -3, 0, because you went left 3. You should have a y-intercept of -1, 0, -1, because you went down 1. Let's take those last two examples and flip them, flop them, reverse them. They gave you the graph, you came up with intercepts. This time they're giving you intercepts, you come up with a graph. Okay, the difference is this time they're actually labeling it x-intercept 3. They're not putting 3, 0, making sure that you know exactly where an x-intercept goes on the graph, not just looking at the points. Find the y-intercept. We'll draw them both on the same graph. I have the liberty of using 2 different colors. Maybe you want to switch pens and do 2 different colors. I'm going to do the x-intercept at 3. 1, 2, 3. Make a point. The y-intercept at -2. Down 2. Make a point. And it says draw a line that has the given intercepts as straight as you can. Other one, totally different problem, different graph. That's why I'm switching colors. X-intercept is -1. Y-intercept is 4. 1, 2, 3, 4. You got 2 points. Draw a line through them as straight as you can. There's your graph. That's a lot easier way of drawing a graph than making that whole table that we made, and then we put X, and we had a domain, and then we figured out, yeah. Intercept, intercept, line. Done. Got it. Real life. Here it is. A submersible, can you read that? It looks kind of blurry. A submersible designed to explore the ocean floor is at an elevation of 13,000 feet. Let me see if I can get it better in there. That's still hard to read. The submersible ascends to the surface at an average rate of 650 feet per minute. There we go. The elevation E of the submersible is given by the function E equals 650t minus 13,000, where t is the time in minutes. That's a lot of words. Okay, first of all, a submersible. You could just call it a sub. E and T makes a little bit of sense. Elevation and time. Could use X's and Y's that you're more familiar with, but E and T is good. Find the intercepts of the graph and state what they represent. So all we're going to do is find the intercepts of this graph. E equals 650t minus 13,000. Let's find the E-intercept first. If we turn t into a 0, that's all gone. And we have a nice no-step solving problem. E equals negative 13,000. And we can leave it like this. We're not graphing it, so we don't have to put it as 0, anything. The elevation, E of the submersible. So when time is 0, it started at negative 13,000 feet. At time equals 0. So it started down at the ocean floor because we plugged in a 0 for time. Let's do it the other way. I wanted to get rid of this. Find the intercept of t. We've got t. What if we turn the E into a 0? Okay, now we have to be careful because we have to actually solve this. 0 equals 650t minus 13,000. I'll go ahead and put a negative 650t over to the other side. Equals negative 13,000. Get this out of the way. And then when you divide by negative 650, take negative 13,000 divided by negative 650. I bet you it's like 20. Negative 13,000. You can do it in your head if you want, but then always check it. Time equals 20. But it says, state what they represent. So at time equals 20 seconds, our elevation is 0. How do you have an elevation of 0? Well, we're talking about a submersible. That means the submersible went all the way up to the surface. It's right at sea level. So what does it mean time equals 20 seconds? It means that's how long it took to get to the surface. It means the submersible's at the top. I'm not going to make you graph the function, but here it is. Identify its domain and range. The domain is always the x values, so 0 through 20. Domain is 0 to 20. And the range is always the y values. The range goes from 0 down to negative 13,000. We should probably write that the other way. Negative 13,000. Between negative 13,000 and 0. So basically you could say, well, at 8 minutes, where was the submersible? At 8 minutes, it was about negative 8,000. At 16 minutes, it was closer to about maybe like 3,000, 2,500 below. But that's the graph representing it. And that's one way to use intercepts in real life, not just on a graph. All right, that's it for your notes. Good luck. And I'm going to leave the same way I came. Bye.